Okay, before we move on to the next topic, I want to practice properties of exponents, please. Okay, simplify. So underline the problem, make 3 lines. Okay, so really you don't have any number bases on top. The only base you got is y. Now there's 2 of them, so we'll have to add. Now the first y is actually 3 times 5 is 15. The other y is just a 7. Okay, does that have a negative or a positive exponent? Positive, it keeps its position, and you can't evaluate that. Why? Because you don't have a value for the variable. Okay, next one. M to the negative 4th divided by m to the 3rd times m to the negative 2nd. So on top, no number bases, just the m. On bottom, no number basis, just the m, but given the fact there's 2 different factors of m, we'll add their exponents. So on top, you got negative 4. On bottom, you're going to take a 3, and you're going to add the negative 2. So 3 plus negative 2 is negative 1. So now, we have an m on top and bottom. What should we do? Well, we should cross out the one with the smaller exponent, which should be negative 4. So you minus negative 4 from the bottom. That's negative 1 minus negative 4. Now, I don't care if you just put that into a calculator or you go plus plus and negative 1 plus 4 is 3. I don't care. Okay? But it's m to the 3 is what you need to get. That's positive, so it stays in the same position. It's on the bottom, stays on bottom. You need to cover the top with a 1. Okay? Can't really simplify m to the 3rd. Can't have an empty top. You can have an empty bottom, not an empty top. Okay, next one. We have a parentheses, and in that parentheses we have negative 5 x to the 3rd, and then outside the parentheses to the 2nd, times 4x to the 3rd. Times. Number bases, you have a negative 5 and a 4. So you put the negative 5 in a parentheses when it's negative, and then times 4. Then variable bases, you have x. You have 2 of them, so that means we'll be adding. So negative 5, 1 times 2 is 2. And then 4, 1, but it's not in parentheses, so do not distribute the 1 to the 3. It stays at 1. X, check the one on the left, it's to the 3rd, 3 times 2 is 6. Then our other x is to the 3rd, and 6 plus 3 gives us 9. Now, that exponent's positive, so negative 5 stays in the same position. Now, when I'm checking for negatives, I don't care about the base, I care about the exponent, okay? Stays in the same position because the exponent's positive. Well, that's going to stay in the same position. And so is that. So everything, they all had positive exponents, they all stay in the same position. So negative 5 to the 2nd gets evaluated, that's 25. 4 to the 1st gets evaluated, but that ain't hard, it's 4. Then times x to the 9th. 25 times 4 is 100. You need to be timesing that in the end. 100 times x to the 9th. Bottom can be empty, that's fine. Okay, we got a real treat on this one. We have a fraction times a fraction. On top of the first fraction we have 6, a to the 4th, b to the 5th. And on bottom of the first fraction we have a times b. Times, and we have one whole fraction of parentheses. On top we have 2ab. On bottom we have a to the 2nd, b to the 2nd, and then after the parentheses we have this 3rd power here. Okay, now extend the line. You can do that on a multiplication problem. You can't on an addition problem, but on a multiplication you can, which is all we've had to this point. Okay, top and bottom we do separately, so I got a base 6 and a base 2 on top. Okay, we have variables of a. There's 2 of those on the top, so we will add those powers together, and likewise on the b, b. Okay. Now on bottom, no number bases. Okay, put the times dots in. I guess I didn't do that. On bottom, no number bases, but you have base A, 2 of them, so that will also be added. And base B, 2 of those, that will also be added. Okay, so let's talk about the 6. It's to the 1. It ain't in a parentheses, so it stays at 1. 2's to the 1. It's in a parentheses, so we take 1 times 3. That would be 3. Now the A's on top. On the left we have a 4, not in parentheses, so it's just a 4. The other A's to the 1, in a parentheses, so we take 1 times 3, that's 3. So 4 plus 3 makes 7. Okay, now the B on the left, we have a 5, not in a parentheses, so it's just a 5. The B on the right, we have a 1, in parentheses, 1 times 3 is 3. So 5 plus 3 makes 8. So 6 to the first, times 2 to the third, times A to the 7th, times B to the 8th. Now on bottom, we have an A, it's to the first, not in a parentheses, so it's just a first. And the other A is a 2, but that is in the parentheses, so I got to take the 2 all the way out here and times by that 3. That's 6. 1 plus 6 is 7, so A to the 7th. We had A to the 7th on top, A 7 on bottom. Now B to the 1, not in the parentheses, so it's just a 1. And then the other B, 2 times 3 is 6. 1 plus 6 is 7. So we have A to the 7th times B to the 7th on bottom. Now, when you have bottom at bases, you need to see if you can compare on the tops. So you got 6 on top, but you don't have it on bottom. You have 2 on top, not on bottom. You have A on top and A on bottom. But we don't really have a smaller one. They're both 7, so we cancel them. We don't put nothing for that, okay? When it's a variable. It'd be to the 0 power, but yeah. And then B to the 8th, B to the 7th. So I get rid of the B to the 7th and subtract 7 from 8, and that ends up at B to the 1st. Okay. So here are my exponents. Is that one positive exponent? Yep, it stays in its position. How about 2 to the 3rd? Yep, stays in its position. How about B to the 1st? That's positive, it maintains its position. 6 to the 1st evaluates into 6. 2 to the 3rd, 2 times 2 times 2, that's 8. And then B to the 1st, when the letter's to the 1st, you can just put the letter without a power. And 6 times 8 is 48. Again, if it's a 1 power, you can just write the variable without it. I mean, I'm not going to count you wrong if you put it, but yeah. Okay. I have a fraction on top. I got 3. On bottom, I have parentheses negative 2x to the negative 5th power. Now, base on top. Remember, the parentheses is just around the negative 2 times x, not the 3. So on top, you just have the numerical base 3. On bottom, you have a numerical base negative 2. Put that in parentheses. And a variable base of x. So 3 to the 1st, and it stays to the 1st because the parentheses is not surrounding the 3. Negative 2 to the 1, but the parentheses is surrounding the 2, so it would be 1 times negative 5. That would be negative 5. And then on the x, 1 times negative 5 is negative 5. Okay, now let's look at all our exponents. That stays in its position, 3 to the 1. This needs to switch positions because its exponent is negative. So it's on bottom. What's the opposite of bottom? Top. Now when you're moving it to the top, the 2 still stays negative. It's just the exponent that turns positive. And that needs to switch positions from bottom to top because it has positive exponent. So 3 to the 1st evaluates to 3. Negative 2. That multiplies to negative 96. Okay. And then x to the 5th. Now those need to be multiplied. Wait a second, that's wrong. That's negative 32. That's negative 32, not negative 96. I'm ahead of myself. 3 times negative 32 is what's negative 96. So that was negative 32. So it's 3 times negative 32 to make negative 96 times x to the fifth. Sorry about that. Okay, 3 left. 3 times x to the negative third times y to the 14th. So we have a base 3, a base x, a base y, all on top. Okay. 3 to the first, none of these are in parentheses, so they all just take down their exponent. He stays in his position. He needs to switch his position to bottom so that he can become a positive 3. He stays. And 3 to the first is 3. Some of these take a while, some of them go quick. Okay, next one. We have a parentheses. Inside the parentheses, we have 3x to the third, y to the negative third, and then outside the parentheses, we have a negative fourth power. So, number bases, you just have a 3. And then variables, you got x and you got y. 3 to the 1 in a parentheses, so 1 times negative 4 is negative 4. X, 3 in parentheses, 3 times negative 4 is negative 12. Then a y, negative 3 times negative 4 is positive 12. Okay, so negative power, he needs to switch position to 4. He switches position to positive 12. He maintains his position, stays in his position because he's already a positive. Okay. So you got y to the 12th, 3 to the 4th, 3 times 3 times 3 times 3 is 81 times x to the 12th. Simplified. Okay, then our last one. We have a fraction. On top of the fraction, we have a parentheses just around a 5x. And then the parentheses closes, we have negative 3. And then y to the 7th. Now, under the line, we have x to the negative 7th, y to the negative 4th. The parentheses is only around the 5 and the x. Okay, so put in your operators. Sometimes I forget to do that, but it's not like it's hard to do. Okay, so the number base I have 5 times x times y. Variable bases on bottom, you have an x and a y. Okay, so 5, 1 times negative 3 is negative 3. Then x, 1 times negative 3, negative 3. Now the y just carries it 7. X, negative 7. These just carry down because they're not in parentheses. Now we need to do some crossing out here because we don't have a 5 on bottom, but we have x to go with x. Negative 7 is smaller than negative 3, so I minus negative 7 from the top. That's me putting a parentheses. Negative 3 minus negative 7. You don't have to put the parentheses if you don't feel it's necessary. But that's plus 7, and that's 4. Okay. So we got negative 3 and 4. Now the y's, well, negative 4 is smaller, so we take that out, minus parentheses negative 4. Plus, that would be 11. Okay, so the 5 has to move its position because he has a negative exponent. Okay, the x maintains his position, and the y maintains his position because they're positive. Okay, 5 to the third. 5 times 5 times 5 is 125. Make sure you put that on bottom because you put that where the 5 to the third was at. X to the 4th, y to the 11th.